Alright, what's up guys? Mr. Fabella here. Today we're going to be learning how to find the area of composite figures or irregular figures. We've already found the area of a parallelogram, which includes a square and a rectangle, triangles, and trapezoids. So now we're going to kind of put those together and find the area of figures that overlap and composite figures, meaning figures that are put together, like a triangle and a rectangle all in one. All right, so let's get started with a few examples. Composite figure is a figure made up of more than one shape. I'll put the actual definition somewhere over here. Let's just go over and review some of the things we've done previously. So you know that the area, okay, so you recall that the area of a parallelogram is base times height. Area of a triangle is 1/2 of that, so 1/2 base times height, or base times height divided by 2. And the area of a trapezoid is 1/2 base 1 plus base 2 times the height. All right, so all very similar, all derived from the area of a parallelogram. So now let's move on to some examples here. Okay, so first example here, you have a shape, kind of looks like a house maybe with a garage. So you have to find the area of the figure to the right. This is kind of neat because you can actually find the area of this figure many different ways. There's no like, hey, you have to do it this exact same way. But there's one way that I think would be the easiest. So what do you think it is? Think about it. Let's see if you get the same answer as I do. What I think it would be is to cut it right there. Okay, so now you can split it up. The important thing here is to kind of keep organized with your areas so you're not overlapping too much and getting too much of an area. You'll see what I kind of mean later on. So we have this rectangle and this triangle here. So first I'm going to find the area of the rectangle is length times width, and length and width of that rectangle is 6 and 10. All right, so that's going to be 60, and it's inches squared because we're talking about area. Now we can find the area of the triangle. So area of the triangle, if you recall, it's 1/2 base times height, and then now it's kind of time to think a little harder about what the base and height is. 1/2 stays there. The base is the bottom, and it's usually the bottom perpendicular to the height. So we know that the height is 4, so we're going to call that the height. So the base is this right here. It's not 6, because 6 is talking about that part. So you're gonna have to kind of think a little bit harder about this. If you're looking for just this part right here, you have to look, okay, what's parallel to that line? So right here, this is parallel. And you can kind of draw like a little line here. Okay, so from here to here, that's 6 inches. Okay, if that's 6 inches, and this whole thing is 10 inches, then what is this missing area? If you said 4, then yes, that's exactly correct. This should be 4, okay? Because 6 and 4 make 10. All right, so I'm gonna fill that in. That's our base, is 4. And our height is also gonna be 4. And then you just multiply that out. 1/2 of 4 is 2 times 4, and that's 8 is inches squared. So now, remember that you're adding these two together. You're getting the area of the big rectangle and the area of the triangle, and you're adding them together. So you have 60 plus 8 is going to be 68 square inches. All right, cool. Let's move on. All right, moving on to something more and more challenging here. Okay, so here it says, find the area of the pool's floor. So we're gonna try to find the entire area, like maybe ignore the bricks around it, okay? Find the area of that. So let's split that up into two things. If it was just say, find the area of the pool without the stairs, that would be super easy, it's just a rectangle. But we have this part right here, and if you didn't know what that was, that is a trapezoid. So let's split it up. I'm gonna have the area of the rectangle plus the area of the trapezoid. So let's do the easy one first. Area of the rectangle is length times width. So we have 28 and 14. So we're gonna do 28 times 14. I'm gonna start using parentheses. so they don't look like decimals. Okay, good. And then 28 times 14, that's 392. And this is feet squared. All right, so that part's done. Let's think about the trapezoid. So the trapezoid is right here. Maybe it's kind of hard to see. I can redraw it over here. There, here. So these sides are the parallel sides. If you recall from what trapezoids are, the parallel sides are the bases. So it's given that this is 6 and this is 4. And then you just have to find the height. The height of a trapezoid is how far apart are the bases. And, oh, luckily that's already given. That's 2. Okay, cool. So let's start filling this stuff in. But first, let's write the equation for that. So it's going to be 1/2 in parentheses base 1 plus base 2 times the height. All right. So we have 1/2 there. Base 1 and base 2, we already said were 4 and 6. And the height, how far apart are they? That's 2. Okay, now it's just doing this. 1/2 times 10 times 2. And this is 5 times 2. And we have 10. Okay, so the area of the trapezoid is 10 square feet, or feet squared. And up here, we said that the area of everything is you just add them up. So 392 plus 10 is 402 square feet. And that is the area of the pool's floor. Okay, here's something interesting because, like I said earlier in the first example, there's not just one way to do it. So I'm going to scroll up to the first example. Okay, before I said there's more than one way to do a problem, right? There's multiple ways of doing this first example. So what we first did was split it up this way, and we got the rectangle and the triangle. You could have also split it up this way and this way for some reason, I don't know why, but you would have gotten a square, a rectangle, and a triangle. You could have split this up. Yeah, you could have split this up as a trapezoid, a triangle, another triangle, and you could have tried to get this rectangle and try to subtract out this triangle and this trapezoid. That's like way too much work, right? But it could be done. So you have to think about what the best way to do this is. So, okay, so you could have done those things, right? So let's look at this. What is the best way to kind of tackle this? There's actually 3 ways that are kind of equally as easy that I think you could do this. So I'll talk about them first, and then I'll just pick one that I think would be helpful. Okay, so one way would be to split it up this way. And if you can think of a different way than these 3 that I'm showing you, just put it in the comments or send me a message or something, because I'm kind of curious. So one way to do it is split up into this trapezoid, and this rectangle. And those trapezoids look like they should be equal. Yep, they're equal. So that's one way of doing it. Another way of doing it is splitting up this way. Kind of the same idea. You have this trapezoid, and then you have this rectangle here. Okay, and then the last way, which is actually what I thought of first, but some of you might not have, is to find, the area of this rectangle and subtract out, some of you guys might think, find the area of this rectangle and then subtract out these 4 triangles. So since that was the obvious one to me, and we haven't done one with subtracting yet, I'm gonna do that way. So let's think of this problem kind of differently, right? So I'm gonna do area of the rectangle minus the area of the triangles, but there are 4 of them, and they're 4 of the same ones. So I'm gonna say 4 of the triangles. Okay, so let's think about this a little bit first before we just dive in. Let's find the dimensions of the rectangle. So the dimension of the rectangle, here, it's not 20, because 20 is just from here to here, right? The dimensions of this rectangle is gonna be 20, and then from here to here is 5, and from here to here is 5. So that means the rectangle would be 30 feet. And then easy enough for the width, it's just gonna be 18. So let's go ahead and do that. The area of, let's do this in a different color. So area of the rectangle is length times width, and that's going to be 30 times 18, which is 540 square feet. Okay, so now let's find the area of one triangle. So eventually we're going to want 4 triangles, but the area of one triangle is 1/2 base times height. Okay, so 1/2, let's find what the base is. So let's take a look at, so let's take a look at, let's say maybe this triangle over here, and I'll rewrite it. I'll like redraw it over here. So this is 5, right? And then, so let's call that the base, I guess, 5 feet. And then let's try to find the height. So that's a little harder, right? Because you're not exactly sure. So this is where like maybe finding the trapezoid might have been easier. But let's keep going. If this whole thing is 18 right here, and this is 10, that means here and here, they both have to add up to 8. Because 18 minus 10, that leaves 8 for both of these. So assuming that they are equal, that means this would have to be 4 and 4. So this is 4 feet. All right, so filling that out, the base I'm going to say is 5, and the height is 4. Okay, let's put that in parentheses. Okay, so I don't want to take 1/2 of 5, so I'm going to go 1/2 times 20, because I can do that, commutative property of multiplication, and 1/2 of 20 is 10 feet squared. Okay, so you're not done. If you're kind of rushing, maybe you're going to add these, because that's what we've been doing. If you're kind of rushing but not that much, you might go 540 minus 10. But remember, there are 4 different triangles there. So I'm taking the area of the big rectangle and subtracting out all 4 of these triangles. Okay, so I'm going to follow what I said right here. Area of the rectangle is 540 minus 4 times the triangles. 4 times each triangle is 10 feet, which is 540 minus 40, because you have to follow order of operations, multiply first. And that's just going to be 500 square feet. Okay, so let's do another kind of problem here. These are overlapping figures, right? I'm trying to find the area. So there's a long way and a fast way to do this. So Charlie and his brother Matthew are neighbors in a complex where they share a patio. What's the area of both apartments and the patio? So the long way of finding this would be to like split it up into a whole bunch of rectangles. So like this rectangle, these rectangles here, this right here, this rectangle here, and this rectangle here. So you have 1, 2, 3, 4, 5 different rectangles. That's one way you could do it, right? But we're going to try to do it differently, because this way is going to be a lot faster. So what I'm going to try to do is I'm going to try to find the area of this rectangle. Then I'm going to try to find the area of this rectangle. But then the problem is right here, that's overlapping. So because you're counting it twice. So I'm going to have to subtract that out, just one of them. So we're going to find this, I'm going to get organized here, find the area of Matthew's apartment plus the area of Charlie's apartment. And I'm going to subtract out the area of just the patio. I don't have to do it twice, because I still have to count the patio. If they said, I don't want to know what the area of the patio is, then you would subtract it twice. All right, so let's find Matthew first, area of Matthew. So let's do this in different colors here. Matthew's in purple. Area of Matthew is length times width, so 45 times 55. Don't get fooled of this 32. That's not the entire apartment. 55 is it. Okay, easy enough. Area of Charlie's apartment is 45 by 55. Okay, so 45 by 55 again. So they're the same exact size. So that is 2,475, and since they're the same dimensions, that's going to be the same for Matthew. So that's 2,475. Okay, so now the hard part is to find the area of the patio, because I have to find the actual dimensions of the patio before doing anything. So let's take a look at this patio right here. Okay, maybe it's kind of hard to see, so I'm gonna redraw it down here. Okay, so first let's try to find this part right here, this width. So look at the things parallel to it. Okay, so we know that this is 45 and this is 22. So that means this right here would have to be 22 plus something, plus that, and that would give you 45. Okay, so 45 minus 22, that would be 23. Okay, so that would be 23. And now to find the length, same idea. Let's see what's given here. 55 is given over here, and 32 is given over there. All right, so this would be 55 minus 32, because 32 plus this part over here, that's going to give you 55. So 55 minus 32, that's going to be 23. So it's another square. 23 squared. So 23 times 23 is going to be 529. Okay, I'm not putting the unit squared yet. I'll just put that at the very end. So now let's follow our formula at the very beginning. We're going to add these up. We're going to add them up. So it's going to be 2,475 plus 2,475. Oops. And then we're going to subtract out one of the patios, minus 529. Okay, so if you do that, you have 4,421. And then now we can put the units in square feet. Okay, so hopefully that helped. I might put in one extra example here in the school, but yeah, hopefully that'll be a little fun, because if you think about the school, it's not just a regular rectangle, it's a bunch of rectangles. So I'm curious as to how you guys would split that up. So as you can see here, I've done all of the measurements for you through Google Maps. I'll link a second video of how I did that as well. So you can take a look at these measurements. I'll also put a link to the file in the description, or the assignment, to see if you guys can actually find the area of the school. So I'm going to make a totally separate video of where I'm going to calculate that, but for now I'm going to challenge you guys to try to find what the area of the school is and try to get as close as you can. So obviously it's going to be an approximate value, like kind of close, because this is going to be measurements from Google Maps and it's not exactly going to be perfect. But if I'm trying to get just an approximation, just to see about how much area is there, this is a really good way to do that. All right, so that's about it. So check this out, and then there'll be another video of me explaining how I tackled this problem, because there are a lot of different ways to try to find the area of this. So yeah, once again, this was compound figures, and I hope that was helpful. I'll see you guys next time.